So today we're going to talk about slope, and slope is something that's a very important concept to understand when graphing lines. So slope is how fast a line rises from left to right. When you think about a mountain, mountains rise up kind of quickly, but there are some mountains that go up much more steeply than others. So you wouldn't want to climb something that's super steep because you might fall. So if you think about it, this line here from left to right is kind of steep. This one here is even steeper if you were climbing up it. And this one here is even much steeper. So think about it in that way. So that's what the term slope is, how quickly the change in y happens over the change in x. So this is a lot of numbers here, and I'm going to explain this by using by naming the points. I'm going to take this point here being 0.2 and this point here being 0.1. What I mean by that is when I plug in the values, if you see up here y1 and x1, that's going to be this x and this y, and then y2 and x2 is going to be this one and this one. So I know that seems a little bit confusing, but it's going to be a lot easier when you see it because it's just a formula. So I'm going to plug in the numbers into the formula now. So my x value for 0.2 is going to go on the bottom there. My x value for 0.1 is going to go here. It's subtract the x value for 0.1. Now if I do the same thing over here, the y value for 0.2 is going to go up here, and then that's going to subtract the y value for 0.1. And when I end up doing the math, what I end up with is the subtraction problem at the top. It's going to be -3 because -1 minus 2 is going to be -3. And that's going to be over what's 4 minus 5, that's going to be -1. And -3 over -1 is the same as, if you remember your division facts in terms of multiply and divide by integers, that's going to be the same as 3. So the slope of this line is 3. So now I'm going to do the same thing with this one over here. I'm going to choose this one being 0.2 and this one being 0.1. And again, that's important because my 0.2 values are going to be those two and my 0.1 values are going to be those two. So when I plug them in, what's going to happen is, in this case here, let's see here, I'm going to plug in y2 up on top, and then that's going to be minus x, or minus y1, so that's going to be -3. And then the other side here, I'm going to be doing x2 minus x1. So when I do the math here, I'm going to end up with 6 minus 3 on top, so that's going to be 3. And then on the bottom, it's going to be 4 minus -2, so that's going to be 6. So simplified just like fractions, that's going to be 1 over 2. So that means that line has a slope of 1/2. Now on this bottom part here, same rules apply. I'm going to do this one, and then I'm going to leave the other one for you to do. So here, this is going to be my 0.2, this is going to be my 0.1. And when I do that, my x value, or my y value here is going to be here. So it's going to be -3, because that's my y2, minus 5, that's going to be my y1, over what's 1/2, that's my my x2, and then minus 9 over 2. So it's going to look a little bit funky, but -3 minus 5 is going to be -8. That's going to be 1/2 minus 9/2, so that's going to be 8 halves, or negative 8 halves. So that's actually going to equal negative 8. And what's negative 8 halves? That's going to be a negative 4. Then when I simplify it, negative 8 over negative 4, that's going to be just 2. So that's a pretty complicated one because it had these fractions in there. But try this one yourself. And again, it's this formula here, and you just have to decide which one's 0.1 and which one's 0.2. When you have a graph, you have to identify the points, and here the points are given. And then you just subtract out and see what's happening with them. So on this one here, I'm going to choose this being 0.2 and this being 0.1. So my y value is for 0.2 is going to be 3. That's going to be 3 minus negative 1, because that's the 3 and then that's the minus negative 1. That's going to be over 6 minus 2. So I do the math, I'm going to be left with 4 over 4, which simplifies to just plain old 1. Now you can have negative slopes as well. So if I look at this one that I just indicated with the blue, so I'm going to choose this is my 0.2 and this is my 0.1. It's going to be negative 3, the y, minus 1, because that's my other y, over negative 1, the change in x, minus negative 2. So that's going to be negative 4 over, that's going to be over 1. So this has a slope of negative 4. These two are kind of weird ones, and we're going to go over why they're weird in a second. But positive slope, negative slope, they're the top two. Now I'm going to do the next one in red, and still it's going to be, I'm going to choose this is my 0.2 and this is my 0.1. So it's going to be y minus y over x minus x. That's going to be 0 over 5. So this has a slope of 0 over 5, which means it has a slope of 0. That means it just doesn't go up at all. And then this last one here, it's even a little bit more odd. The y, I'm going to choose this as my 0.2, this is my 0.1. So in this case here, it's going to be 7 minus negative 3 over 5 minus 5. So that's going to be 10 over 0, which there's a funky word for it. It's called undefined, because you can never divide by 0. So it's just one of those answers that you can never work out, and if you divide by 0 on a calculator, you'll get an error message. So the letter we use for slope is called m, and if you look at these, this is when m is less than 0. That means it's going to be going downhill from left to right. So this would be an example, this would be an even stronger example, or this would be even a steeper example, downhill. When the slope is bigger than 1, it's going to go uphill from left to right. When the slope is 0, that's always going to be a horizontal line. And when the slope is undefined, it's always going to be a vertical line. So there's a lot more variety in those first two than in the others. So now in terms of change, rate of change, that's what slope is really about. And we can apply this in word problem format. This table shows the cost of paint to paint a house for a given number of hours. Find the rate of change and cost with respect to time. So I'm going to actually treat this, the top one, as my independent variable, my x, and this being my y, as the cost depends upon the time spent. And so now I'm just going to plug in this as being my 0.2 and this is my 0.1. So when I do that, I'm left with the change in y, which is going to be 135 minus 90. over the change in x, which is going to be 6 minus 4. So that's going to be 45 over 2. So that means for each 2 hours, you spend $45. And this is very similar to this type of problem. Same thing, just the change here is going to be 9. The change here is going to be 4. So if this is my x and this is my y, the answer is going to be it's 9 gallons evaporated from a swimming pool every 4 hours. Now when you're looking at this graph here, it says the graph shows a ferry trip across a lake. Describe the trip in words. So here, if you're looking, the distance is here, time in minutes. This first part, we don't go anywhere. So that's probably when it's at the dock. Then it leaves, and when it leaves, it starts kind of slowly. So this is when it's starting to speed up. And then it gets going here, it's going faster because it's going more quickly over time. So it's speeding up again. And then the last part here is when it's at the dock and it's not going anywhere again because there's no more distance added. So it's going to be at the dock again. And these graphing things can tell a story. So slope is just the change over time, or the change of y over the change in x. And really it's just a very useful thing to determine how fast something is changing. And frequently it's called the rise over the run, or the change, and this is the formula, change in y over the change in x.